All right, so good afternoon for those of you who are joining us on the Eastern time zone and also Atlantic. Good morning to those of you who are joining us Central Time, Mountain Time, and Pacific Time. We're going to get started right away. So welcome to our Q&A panel with Rack Safety Experts. This is our first webinar event for the month of June. And for those of you who are looking to get a little bit more information on this event, you'll find it here on the screen. So the purpose of this event is as follow. Of course, it's being able to discuss previous submitted questions. So since the invite, we have received quite a few questions that came in. So we are going to go through those list of questions. Some of you who are online right now, anticipating those answers. But for those of you who did not get a chance to send us your questions, we do have a live forum. So simply, if you see there on your screen, depending on the platform you're using, top of your screen, bottom of your screen, you're going to find a little Q&A button. Click on that button. You can ask your questions. We're going to do our very best to answer those questions live. And in the event that we're not able to get them through those questions, we will try to reach out to you after the session as much as possible. Last but not least, the most important purpose for this event is, of course, to enhance knowledge and understanding on pallet rack safety. And with that, we hope that you're going to be able to take away some valuable information from this session today. So for those of you who don't know who we are, Damotech, we are your rack safety partner. We work with various different companies. We are the largest rack safety service provider in North America. We are headquartered out of Montreal, Canada. We service all of North America. We have over 30 years of experience, and Damotech is specialized in pallet rack safety services and product solutions from a variety of different offerings, from rack conformity inspections. We can offer load capacity calculations. We have rack safety management software. We offer a variety of different product solutions, from repair to warehouse protection, and of course, various types of rack safety training. So for those of you who don't know me, my name is Eric Manaigre. I'm the Vice President of Sales here at Damotech. And I'm pleased to welcome you, my two co-hosts. So starting off with our first expert panelist, this is Mr. Charles Carbonneau. He is our Chief Engineer here at Damotech. Charles is a structural engineer and Ph.D. with over 25 years of experience in structural dynamics, and he's renowned for his in-depth knowledge of racking systems and innovative rack safety solutions. On that note, Charles, good afternoon to you.
Good afternoon, everyone.
Perfect. And next person is our second panelist, or our expert panelist. This is Marc Rousseau. Marc is our VP of National Accounts and Strategic Partnerships here at Damotech. With as many years of experience, Marc is a subject matter expert in his field and has become instrumental in developing safety solutions and programs for many Fortune 500 companies that we do business with today. On that note, Marc, it's an honor to have you on the call. Thank you for joining us.
Thank you very much.
So let's go through the questions, and there's a lot of questions coming through. So we are going to start with the first one. So this is a question that came in from Dennis. Also a similar question from Harold. So I'm going to try to package them together. What are the standards or the requirements regarding minimum clearances between pallet racks and the walls of the building or column posts?
Yes. So we don't know really if the calls are on Canada, in Canada or the US. So I'm going to answer for both just about every time. So Canada and the US have just about the same calculations for the distances from which a rack must be located from any other type of structure. And that could also be another rack. For example, if you've got a rack going in this direction and you want to have a rack in that direction, they also should be separated by a certain distance. Now that distance has to, if we do the calcs, they have to be done with the seismic behavior of the rack system, the total distance, and also the total distance that can travel the other structure. So you take the square root of the sum of the squares of these distances, and that's what you get. Now, not fun, because if it's a building, you have to calculate the seismic behavior of the building as well as the one for the rack. So the US code provides us with a nice article that says, in the down aisle direction, you should be off from 5% of the total height of the structure, top beam elevation, sorry, away from anything, right? Whether it be a column that's going through the rack, you should be off of that column 5% of the height of that beam, that top beam. And in the cross aisle direction, then it's 2%. So that makes things rather simple.
That's a detailed answer. Thank you very much, Charles. And there will be a test at the end for all of those of you online. That's wonderful. All right, next question. Actually, I'm going to ask this question to you as well, Charles. Very common question we get here at Damotech. This question came in from Rick. I have load capacities on a rack, but they date over 10 years. Are they still valid?
Okay, so the applicable rules here, and I've never seen something clearly defined in the codes on this, the rack design codes. But for a building, for example, a building structure, if you don't modify the structure, it's good. It's not going to collapse because we changed the codes. Now, codes always evolve every 5 or 10 years. There's a new version that comes in, we refine the calcs, it gets a little bit more complex sometimes it's simplified, but you should be good if you don't modify the racks. Now, racks being very, very much living entities, they change all the time. They get damaged, you swap, you repair them, you modify stuff in there, you change beam elevations. You should look into having the new codes applied whenever you touch a rack. That would be what we do for buildings, and I think the logic also applies to a rack.
Thank you very much, Charles. We're going to get Marc into the discussions. Marc, actually, we got these questions a fair bit here. I'm going to summarize the 2 questions that came in. One from Kevin, another one from Ryan, and this is regarding responsibilities. So what are my company's responsibilities or mine as a warehouse manager regarding the safety of my rack? Another angle to that question is, what are my responsibilities as a warehouse manager regarding rack safety?
Sure, that's a great question. I think it's kind of twofold from an answer perspective. One, many companies will take it upon themselves to set guidelines and responsibilities for their warehouse managers. So there will be an EHS or a safety department that kind of has general guidelines for, hey, take care of our people. Here are the things you want to look out for with respect to all things going on in a warehouse, whether it's pedestrian traffic, whether it's forklift stuff or racking. Absent a company imposing certain responsibilities on its employees and its leadership within a warehouse, OSHA has your back in a way if the company doesn't put those responsibilities in place. And it's the general duty clause. It's from the 1970s. Basically, I'm going to read just a few bits of it here. That each employer shall furnish to each of their employees employment and a place of employment which are free from recognized hazards. So absent the company kind of telling you what to do, OSHA will impose on you that general duty clause to ensure you're doing the right thing by your workers. Now, whether that encompasses having racking that is inspected on a regular basis or that is free from defect or free from impact, all those things kind of get lumped in to that responsibility. So it's a monumental responsibility when you think about it. I mean, but then again, anything within a work environment has certain hazards, and I think the racking just now makes its way into that overall envelope from a responsibility perspective.
Wonderful. Thank you. Thank you very much,
Sure.
Marc. Here's another question, and we do get this question a lot. I'm going to ask it to Charles. I'm going to try to package this up together. This is a question that came in from Jonathan, David, and Noah, and it's all regarding how to determine, the damaged upright. So, what determines a damaged upright? How many dents can an upright have before its integrity is compromised? Are there a certain level of deformation that have to be looked at? What are ways to look at that or address that?
That's an excellent question that comes time and time again. And the answer is quite deceiving in the sense that it depends. And that's a typical engineer's response. Well, it depends. And so we try to guide our clients into observing the damages. You know, a 5-year-old knows that an upright is damaged. Looking at the column, oh, you know, it's not the same as the rest of the column. It is deformed. They know it. We can recognize it. But how bad is it? So oftentimes I talk to clients about the fact that imagine that the company that provided the racks initially look at the damage. You know, will they still guarantee the capacity of that upright? And you know they're probably not going to, and they're going to say, well, you know, you should repair or swap that upright. As to dents and little bumps and dents to the columns, they're not there's no significant loss of capacity to a point where as soon as it's dented, you need to replace it. But indeed, when you have like it's slightly twisted and then it's dented up front and then it's dented to the side, all that in the first 12 or 18 inches of your upright, you did lose some capacity. There is an effect to it. And by how much is really difficult for engineers to determine just by looking at it. The only real test that we know is that we'd have to take it out, put it under a press, you know, under the same conditions, same beam elevations, completely crush it. And then we could come back and say, yeah, it was fine. You still had some capacity to go. There's no good damage when we look at it, because indeed, we know that it affects the capacity. We don't have safety factors that include damages when we design rack. They are highly optimized structures, okay? And there's no factors taking into account the possibility of these damages. So with that, we have a 1, 2, 3 rule that we try to explain to clients is typically for cold form columns, if you have a dent below 1/8 of an inch, frontal impact, for example, you know, take note of it, take pictures, put it in your records, but it's not something you have to act immediately, right? It's something to consider, and maybe it raises a flag. Well, maybe we should protect the column. Something's going on. Is the aisle wide enough? There's all kinds of problems. All in all, you know, to decide what do we do with this thing, we recommend using an expert that does a yearly inspection. They come in, they are engineers, they look at it, they understand how gravity acts on those. If you're in a seismic zone, they understand also the forces at play. And then they can decide and give you an outline. Okay, this needs to be acted now, immediately, unload right now, do something about it, replace or repair. And this can be part of a maintenance program, you know, during the next 3-6 months. Think about replacing these items. It's a complex question.
Yeah. So on that note, I'm switching over here to the live questions coming in. So this is a question from Ali, another anonymous attendee, very similar question. So the first one is there any code requirements for inspection frequency of racks in Canada? And the other person, very similar question, how often should racks be carefully inspected for damage?
Okay, so just the first part of the question. So yes, indeed, in Canada, if you take, for example, WorkSafeBC out west, they outline about 12 parameters that can influence your frequency of inspections. It's not a clear number saying, well, you got to do this, but they also go in the direction where they say, oh, well, you should have an expert come in on a yearly basis. And it sounds markety or selling wise, but yeah, having a set of eyes from engineers that really understand how loads go down is really interesting. And also, when you look at an upright, it looks rather simple, but there's about 50 things to observe on a single upright. If you have 1,000 of them, it's 50,000 observations. You need someone really, really patient to go through this. So again, Ontario has something similar, I know. Manitoba, I believe, and Quebec also have these kinds of recommendations. They cannot say it's got to be weekly, although they will say, yeah, perhaps weekly in these zones where you have an immense traffic, a daily traffic of unloading and loading and whatnot. And monthly, I think, monthly for regular inspections by employees, yearly by a third-party company.
Wonderful. So hopefully, Ali, that answers your question. Marc, here's a question for you. I would like to implement a rack safety program for my company, but I'm unsure where to start. I think you get a lot of those questions on your side. So what do you recommend? What are the procedures or what are the steps? What's a starter?
Sure. Well, certainly I think getting educated with the overall needs of rack safety are important. And we have not to promote our website, but we have tons of information for the person who's more novice to understand that things are important. We recently developed what's called a Rack Safety Flywheel. And the idea behind that is to have an overarching concept and structure around the fundamental elements of rack safety. So I would encourage folks that are wondering, where do I start? Why is this important to take a look at the flywheel that we developed? We first presented it at ProMat just a few months ago, but the fundamentals of it are like why is this important? Why rack safety? Then we go into the basic building blocks of why an employee believes this is important. So from an employee well-being perspective to an operational efficiency to just an overall compliance, those are three legs of the stool that help us understand why rack safety and is an important thing that we want to start focusing on. And then it goes into having almost an equal amount of third-party expertise and in-house knowledge. The last thing you want to do as you set off in your program is to be 100% reliant on outside experts. I think initially you'll need to do that, but eventually you'll want to balance that out between, okay, I'll have somebody come in on a periodic basis. Maybe it's once a year, maybe it's once every couple years, or even more frequently, but you want to bridge those gaps with internal folks that now understand the importance of rack safety, that could identify damage on their own, so that you don't have these huge gaps in time between, oh, I've got all these things I have to do because Charles sent an inspector at my warehouse, and then a year goes by, no one's looking at the racking, and now you're waiting a year before you get another set of results back. So I'm a big proponent of educating the masses, ensuring that we empower our employees to be able to identify things. And then we have all these other surrounding building blocks of the flywheel. We talked about inspections, the quality of the reporting, the action plan that we put in place to maintain the racks once they're damaged, the prevention elements so that we prevent damage from happening. Then, of course, having it all tied together by having a tool of some sort where we could track the progress of things. So the flywheel is a great way to understand, I think, the importance of rack safety, and I would direct folks towards looking at that. Again, it's not a salesy element. It's something that's meant to be agnostic to the industry, but I think it's a good step forward towards understanding rack safety.
All right, on. Thanks a lot, Marc. I'm going to ask this question to Charles. This is a question that came in from Gary. It goes as follows. When securing end caps, do you need row spacers? And I know that's potentially maybe a broad question, but to get a little more specific, single row racking, how do you ensure that they are stable? So I guess the question is, how do you ensure that racking is stable? And at what point, do row spacers have to come in or don't come in? I'm not sure if that questions make sense.
Yes, I'm not familiar with end caps, exactly what that meant, but we can have a discussion on the stability of single aisle or wall racking systems. The designer is responsible for specifying how to anchor the rack, how to design it, every element of the rack, the anchors, the base plates, and also the overturning capacity of that rack. So if it's a very the height to depth ratio is rather high. If you're above a 6, you start to really look into it rather deeply. If you're above 8, that's a very special case. Above 8 is a very, very lean system that you will probably not be able to simply anchor. You will probably have to use cross aisle ties. Now, we already talked about in the first question the separation with the structure. You don't want to attach your rack to the building structure unless there is the interaction of the two structures is considered in the analysis of both of them. So that's still a possibility. It's something rather hard to do, but it is still a possibility. So otherwise, the design engineer for the rack does not has to specify, where and how to attach the rack. I'm not sure that totally answers, but so I'm going to reference LARCs. So LARCs is the acronym for Load Application and Rack Configuration Drawings. In the more recent US code, they just said Load and Rack Configuration Drawings. I don't know where the application word went, but it doesn't matter. The approach is that it's like a building structure. It has to be designed. It has to have plans that are stamped by an engineer for each state, each province, and it's got to have somewhat detailed calculations that we can reference at one point. So you reference that document, and in there it says exactly where to have your cross aisle ties, if any, row spacers, if any. They are detailed exactly where. You can't play with these things. You can't remove them at will because they are really designed and considered in the capacity of the rack.
Perfect. Thank you very much, Charles. A very common question that we got here. So this is a question that came in from Dustin, Tim, Flav. I'm going to ask this question to you, Marc. It's all regarding rack repair. So how does one person asked the question, how does the rack repair kit work? Another question is, what makes repair more optimal than a quick replacement? What's the rack repair versus a rack replacement? Are you able to cover those questions?
I am. So it's a big question.
It is.
We could
multiple questions,
webinars on that topic itself. So from a repair kit standpoint, I mean, there are a couple of approaches out there that people will use. So I'll start from the very top. A repair solution has to be engineered. So if you have damaged racking and you are looking to an alternative to just replacing the racking, now you may want to look to an alternative because maybe waiting for an upright is longer than you have to wait. Maybe there's an industry constraint somewhere in the supply chain, and then rather than the upright being ready in 12 weeks, it's going to be in 26 weeks. We've seen that take place during the time of COVID and when demand was extremely high and the supply chain was very constrained. So that could be one reason that you want to opt for an engineered repair solution. It could be that the OEM, so the original equipment manufacturer that you have in your building for your racking, no longer exists. The racking is 30 plus years old. You acquired the racking and OEM nowhere to be found. And now you don't want to just completely ditch the existing racking. You want to address some damaged uprights in your facility. So that's another example where you might want to opt for a repair solution that's engineered that can address your concern. Now, there's a litany of other things like, some repair solutions like ours don't necessarily always require the full unloading of an upright. We have a patented device that we latch onto the upright that supports the load in the uprights as we make a cut, remove the damaged portion, and then slide in our kit, bolt it, and anchor it. Now, that's our solution, and one that has a bunch of advantages to include the speed of manufacture, the speed of install, and for I would say higher end repair kits, and ours, we call it the Pro line, is almost comes in with a built-in protection to future damages. So as I try to synthesize my answer, a repair kit fundamentally is an engineered solution for addressing rack damage. It restores the load capacity of the affected upright. It mimics the rack configuration or style that was there before. And if everything is great, you're not going to have to do any on-site welding, and it comes in with built-in protection. From that standpoint, now you start comparing what the value add of different potential suppliers might be. But I would ask folks, look for the quality of the manufacturing, look for the warranty behind the product, the speed of manufacturing and install, and then you could have a decent understanding of, hey, Mark, or is this better to be replaced or repaired? So I think with all those things, our customers will be able to come to an intelligent decision on how to render each scenario.
Perfect, Mark. And actually, you said the word welding, and actually perfect segue for the next question here. So this question came in from Michael, and I'm going to ask that question to Charles. I think it's a little bit more technical. Historically, I've heard of customers using local welders to come and fix damaged racking. Is that a practice that is safe to use? Is it recommended? What are the what's the feedback on that?
Okay, so it is not recommended, knowing that you really need experts to look into it, especially if you're welding cold form steel, which is rather thin. You need a very good control of the temperature, and the know-how of the welder has to be up to par. I think we have a blog on this. By the way, we haven't mentioned those, but Damotech's website, you can do searches on different topics. And if you look for welds, I think you're going to find it quite easily, where we talk about weld contamination. So oftentimes we see this, when you look at a weld and you see burnt paint around the weld, that was surely because there was no adequate weld preparation. And that's a clear indication that the welder was not knowledgeable enough to do it. Now, the RMI on the US side also has many recommendations, including saying, if you want to do that, you need to have an engineer that designs how it's going to be welded, that specifies it in a drawing, that is present when they do the welding, he's got to supervise the activity, and he's got to perhaps stamp what has been done afterwards. It's really hard. It's really costly. So the industry kind of agrees that bolted repairs are much better.
That's a good answer. Thank you very much. And I guess staying on the topic of repair, this question I'm going to ask Mark. This question came in from Ryan. So, is there a time that it is best to either repair a rack? Is there a best time in order to replace? Are there any recommendations on that?
Yeah, I mean, I alluded to it a little bit in my previous answer. I tell folks, now we're in the rack repair business. We're one of the larger segments of our business. If you have a damaged upright and you have some spares that you have, somewhere located in your warehouse, use the spares. I mean, no one's going to tell you don't replace the upright, especially if you've got some spare stuff. But often, folks, because there will be different styles of racking in a warehouse, they won't have spares of everything. So they're going to have to now look at procuring themselves some uprights. And as I mentioned before, if your need is extremely critical and you can't wait umpteen weeks for that upright to be shipped and then installed, if you can't find that upright anymore because that OEM went out of business, or if you're also looking to minimize the operational impact of replacing an upright versus repair. So repair has a great amount of advantages, and certainly our website has some, I would say, less salesy ways of evaluating it from a cycle time, from an installation perspective, and just overall I would say, impact proof design of the kit. So I mean, at a very high level, I would just approach it that way. Replacing an upright or replacing a damaged component, absolutely the right thing to do if you have spares around. If you don't have those spares and you're looking for the value proposition behind repairs, just do the homework. Make sure that the folks that you have repairing the stuff that you have the engineering behind it to support it, so that you know that when that thing is in there and you're inspected or somebody else comes to look at it, that the documentation is there to help out. So
perfect. Thank you very much, Mark. Yeah, that kind of wraps up the, I guess, the dialogue around our rack repair. I'm going to go to the next question. This question came from Joe based out of New Jersey. And his question is as follows. There are many older warehouses with challenging sloped floors in my area, in my market. Can you please talk about proper anchoring and limits to shimming? I think that's a question for Charles.
There are limits to the height of a stack of shims that you can have. And it is, I believe, if I remember well, it's 3 times the diameter of your anchor. So you have a 1/2 inch diameter anchor, which is rather typical. You cannot stack more than 1.5 inches. And by that time, when you're at 1.5 inches, you're not too far from using the other hole in your upright. And there's no problem with having staggered beams, kind of, on the left, because you're deep down, the floor is going down. Maybe you have 3 holes before your first beam, and on the right, you might have 2 holes only, and that's okay. Now, all of this, right, is governed by the amount of out of plumb that it's going to generate if you're not straight. If the whole rack is, the beams are all going slightly in a slope, the whole rack wants to follow, because these connectors are the ones providing lateral stability down aisle. Cross aisle is another question where it's a bit easier to just shim the back leg because the distance are smaller. It's got a much bigger effect in shimming. But just so you know, and I'm just going to repeat that the basic rule is you shouldn't have more than 0.5 inch over 10 feet of height of out of plumb. And 0.5 is very typical in cold form steel columns. It's the size of your front hole. If it's a teardrop, the teardrop is a little bit bigger. I think it's almost 3/4 of an inch. But that's a reference, just so you know. At 5 feet, if you've got a 1/4 inch, you're at that limit now. So you're trying to shim the system so that it stays straight once you load it. And the tolerances for unloaded racks should be 1/2 of the loaded rack tolerance that I just gave you. So it would be 1/4 inch over 10 feet of horizontal deflection maximum. So I hope that gives you an indication. The MH16.1, which is the US pallet rack design code, has indications on these kinds of limitations.
This one's a little bit more technical. Not sure if you would have this answer, Charles. So it comes to pallets on racking. Is there any guidelines on how much a pallet can overhang from the front or from the back of each shelf? I guess they're talking about the beams, right? So is there anything around overhang when it comes to pallets on a pallet rack?
Yes. So typical, I'm going with that word. Typically 3 to 4 inch of overhang for a regular pallet, right? But I kind of feel that the question is probably for irregular pallets, right? Where maybe you have an overhang of 1 foot in the front, 1 foot to the back. So again, that's a type of question where we say, well, it depends. It depends. Is this like a system where you have 4 or 5 beams deep, and then the front is going to have an overhang of, I don't know, 24 inches. And then that front beam is going to be overloaded when comparing to the tributary area that the other beams are capting. And that has also an influence on that front column. If it receives more load and it was not intended for that, we have a problem. So it comes back to answer the question very generally, it comes back to, was it designed for that? And if so, the engineer that stamped the drawings and said, that's going to be it, and I approve it, you're good. And you can do that also after the fact. If your original LARCs don't include that type of overhang, but you want to go to it, and an engineer says, yes, it's safe, yes, it's designed for that, you're good to go, then that's it.
Thank you, Charles. Next question came in from Zachary. I'm going to ask this question to Marc. What are the different guardings for racks for my company that my company can use to prevent damages from happening? So I know it might be a bit of a general question here, but what insights can you share regarding different guarding solutions for rackings?
Yeah, no, that's good. I mean, I'm encouraged by the question itself. Sometimes I think folks tend to be reactive to rack damage, so they wait for the upright to be hit before they address anything. So getting upstream of that damage, I think, is an important thing. So from a protection standpoint, there's of course there's multiple technologies out there, or there are varieties of rack column protectors that'll completely encapsulate the upright, so that there's an avoidance of damage there. Some technologies like ours will use anchors and a bull nose to ensure that whatever impact energy is put into the upright gets transferred primarily to the anchor. Others will be more in front of the upright, so there's no impact energy actually being transferred to the upright at all. I won't say negatives about that, but by being further in front of the upright, you're taking more space into the aisle, which some folks can't afford because of the widths of the aisle. And some technologies will be so tall that as you impact that protective device that is in front of the upright, over time, the anchors on that protective device will loosen, and you're going to end up having the protector being the thing that's now impacting your upright. So again, not to denigrate other technologies out there, but just do your homework when it comes to protecting the upright itself. Beyond that, there are ways to protect the end of aisle. So there are end of aisle guards. Sometimes it's angle iron that's been anchored into the floor. You've seen some racking manufacturers put railings on the ends of the uprights. It's just a way to ensure that as pallets are stacked at the end of an aisle, that they're not accidentally shoved into the upright, thereby causing damage, thereby causing a need to replace things. So there are ample technologies out there that have steel anchored into the slab to prevent pallets from impacting the uprights. You can get even more, I would say, creative by, if you're in a drive-in situation, there are rail guides that effectively just prevent the forklift from hitting anything. You're just on that lane, and you can't divert left or right. And of course, we know of wire guidance and those kind of things. But fundamentally, in my view, there are just really two varieties. It's either something that's going to be clasped onto the upright, where you're encapsulating that column against damage, or you're in front of the column, thereby preventing damage from ever occurring. So I love the question. I'm happy people are thinking about ways to protect their assets. And there's, again, ample technologies, but like anything else, do your homework, look at the cost benefits of each approach to the protection.
Perfect. Thank you, Marc. There's a live question that came in. I know, Charles, I think you're about to answer it there. I think you're typing away here on it, but it does tie into another question we received ahead of time. And that's regarding, how to monitor, weights or pallet weight on racking. So the question we just got live here is, what is the best way to monitor weights on a given rack? And I'm going to tie it in with another question that came in, Charles, from Noah. Is there any best way to ensure load being distributed equally? I think the question on this one specifically is, sometimes, pallets can be loaded all on the top, all the bottom. Is there anything that should be kept in mind when loading pallet racking? Does it require to be loaded evenly just through even distribution, or can you have concentration of loading pallets on the very top, bottom, et cetera, et cetera?
Okay, so again, we're going back to using the LARCs, which outline specifically what is the maximum expected load on each beam elevation. In the US, we also work with the average design load. So you have to understand the beams have a certain capacity limitations. Usually they're not going to break because they're designed to be able to withstand at least twice the maximum load. But by then you will see that it's bending a lot and it's getting a bit scary. So usually the design is controlled by the deflection, the vertical deflection. And sometimes perhaps you've seen this, you walk down an aisle and you see all the beams waving down like this. And that's perfectly normal because the tolerance is like, again, it's the length of the beam divided by 180. Which is something that we don't do in buildings, of course, because if you were seated in a chair with that deflection, you would just roll down the middle of the span. But for racks, this is totally acceptable. So these LARCs will outline, you know, if the top beam is designed to receive like double stacking, that's possible. We don't necessarily like it, but if it's designed for that, why not?
Go ahead.
Why not? Yeah. So you do your double stacking at the very top. You're not in a very high seismic zone. You don't worry that they're going to topple. We don't encourage it by all means. But if that's what you have in your LARCs, you can do it. Now, worrying about that distribution, it shouldn't happen because if you need to have bays with higher capacity, they should be designed for that because ultimately the column has to be able to take the load. And if not the column, well, the concrete slab has to be able to take that load. And if it's not designed for it, you're going to crack it, deform it, create the out of plumbness, and then a hell of a problem to try and solve. So yeah, I hear about that, you know, the problems of distribution of load. And if all of the pallets are below or exactly at the maximum load expressed in the LARCs, you're good. You're not supposed to load a rack with a single pallet that is over the maximum load expressed in the LARCs.
Quite a few live questions coming in here. This is one from Valerie. So Charles, we're talking about, you know, LARCs and LARC drawings. The question from Valerie is, are we required by US code to have the LARC drawings of the rack?
Yes.
That is your simple answer.
So yeah, very simple. So the spirit of this is you want to be in control. That's it. Whether it be an engineering report that says, here are your load capacity, this is it, right? If it's in a form of a drawing, it's in a form of a calculation report or a report, something that says we're in control and we're trying to monitor the maximum load that we're putting in the racks, but the rack has been analyzed according to the US code. And we do take into account the seismicity of the site that we're at and the types of racks that we have and whatnot. So recently, by the way, I'm just going to little parenthesis here. So Canada and the US, there's quite an awakening since I would say 2015 to make these advances in the technology and the refining a little bit that type of industry. Racks hold more load than the building they're in, roughly. You know, of course, if you're in a zone where you have like 5 feet of snow on the roof, yeah, it's getting really, really heavy. But racks are highly optimized structures. There's a lot of redundancy, okay, but not so much in terms of lateral capacity under seismic or impacts, you know, small impacts or the out of plumb effects. Just so you know, in the design codes for buildings, it's been like that for years. Whenever you design something and you put it straight and then you load it, it's never straight anymore. Not even a building. They kind of lean somewhat. When you have multiple columns that repeat just like racks, they tend to, in the end, it tends to not show up too much, except if your floor has a definite slope, there's some kind of issue with the floor, or maybe like the question that we had for New Jersey. Maybe that's the nature of the warehouse. Yeah. And so whatever you do, it kind of leans into it, and that forces your beam connectors. So whenever there's an additional force applied to the system, it's already, torqued, and you might either damage your beam connectors, the columns themselves, the base plates and whatnot. And the vertical load, once you're not centered anymore and you're like this, gravity just by itself wants to push you away more and more and more, right? So that's what the codes are trying to do. And since 2019, when the Canadian code came out, much more stringent on the seismic analysis that you need to do to certify a rack system. And in 2021, the US code also. And now it's not that it was not there, it's always been in the codes. You have to analyze and take care that there's seismic events and there's impact loads, when you drop a pallet, not impact load when you hit the rack. But you have to take all these load configurations into account. And now they're just pushing a little bit more. You cannot design a rack just by using a load capacity chart anymore. Can't do that. Even though you're in Toronto and there's not a whole lot of seismic forces, you still have these notional forces pushing on the rack, and they have to be studied.
Good answer, Charles. And I know that there was also a blog that we have on that. So I think the name of the blog is "What is a LARC and why do we need them?" So a good read there for those of you who want to take a look at our website. We're getting really close out of time. I think we've maybe time for one, maybe max two more questions. And there's some good questions that are coming in. Should we worry about fatigue fractures due to repeat loadings? Are there any design guidelines?
So indeed, racks are prone to being loaded and unloaded, but it is not part of the load combinations that we have to look into when we design racks, okay? Because the cycles of loading and unloading have to be like in the tens and 20,000s of loading and unloading before you get appearances of cracks due to fatigue, right? And racks, we don't have that kind of history so far. Maybe in the upcoming years, there's going to be something that we need to check, but so far it's not even in the design codes.
Perfect. Thank you. And we're going to go this last question, and I'm going to ask Marc. So this one kind of, changes from racking, going more towards forklift drivers. And I know we do get asked this question every now and then. Should I implement something regarding forklift drivers to avoid rack damage? So I guess the question comes in, commonly we see lift trucks hitting the racking. Is there anything I can do to prevent that from happening? What are best practices to address those typical types of accidents?
So the answer is yes.
Thank you.
So yeah, a little cheeky here towards the end of the presentation, but all in all, I'd say, look, I mean, of course there are, and I would approach it two ways. We're certainly seeing a decent amount of turnover in forklift operators as, the demand for more warehousing, more racking, folks are deciding they want to do something else with their lives. They don't want to be forklift operators. Or so you have a lot of newbies, hate to call them that, but that don't necessarily know or have the experience to do the right thing when it comes to driving a forklift. So certainly there are all the permits and the licensing and the training from just basic operation of forklifts. I think the thing that has to be expanded to the types of uprights that we're dealing with. If you're in a VNA, so very narrow aisle, if you're in a drive-in situation, pallet flow, all of those, you have to know your environment so that you're operating within the right way. If you're working in a freezer, you've never worked in a blast freezer, holy smokes. I mean, you just want to go in and come out, which oftentimes means more velocity, which means a greater risk of impact. Layer onto that is that corporations that are trying to be nimble, quick, respond to demand faster, are motivating their employees to go faster by giving them bonuses, by having their comp tied to the speed of picking and all. So these are all things meant to speed things up, which with more velocity means more risk, which means a higher probability of impact. All those things being said, and if I step away from the training of folks on the operation of forklifts, I think the piece that is often missing is how to sensitize forklift operators to the impact that damage has to racking. If they understood what a half inch or an inch or multiple hits to an upright can potentially do to an upright, and what the consequence of those hits can do over time, which means a potential collapse, they may be more keen on being careful as they operate around those structures. So I think it's a two-part answer.
Yeah.
The operation of the actual vehicle and how to do that correctly. And then there's the element of, do I now fully understand what the consequence is of my action in running into an upright? So I think there's an employer responsibility. There's also an employee responsibility in driving that heavy machinery around uprights.
Thank you very much, Marc. That was very insightful. Charles and Marc, thank you very much for your insight, for your knowledge, and hopefully helpful for our attendees. Before wrapping up the call, I just wanted to share, for those of you who are looking for a little bit more information, please do not hesitate to go to our website. We do have other webinars, live recordings that we've done. We've done another Q&A in the past. So very insightful, good information you'll find there. If in any chance you're looking for some additional information from what OSHA is looking for, potential other elements on how to improve rack safety, demo information, we have that available through that portion of the website. Again, that's damotech.com/webinars. We do have, Charles alluded to a few times, so we do have blogs, a lot of information, those details regarding, LARCs, shimming, the clearances are required, all that. You'll find that through our blogs. You can explore those blogs at damotech.com/blogs. And with that, hopefully this session was knowledgeable for all of you. Please do not be afraid to contact us if you need any help to navigate warehouse safety, no matter the questions. We do have experts, beyond Charles and Marc. We have a large crew of field support specialists and engineers who are there to listen to your needs, and of course, wanting to help you achieve your safety goals. We can help you with your warehouse to operate more efficiently, safer, through conformity, rack safety products, employee training. We have it available. On that note, thank you very, very much for joining our session. Hopefully, as I mentioned, the session was insightful, and we hope to hear from you some more offline. Otherwise, have yourselves a great day. Thanks for joining us, and until next time.